Hello friends, in this video we are going to discuss the previous year GATE question number 21. This question is from GATE 2016 exam. Let us read the question. The voltage Vs across and the current Is through a semiconductor switch during the turn on transition are shown in figure. Okay, so voltage across and current flowing through the switch they have given. The energy dissipated during the turn on transition in millijoule is, okay, so our task is to find energy dissipation. So energy dissipation means what? The power into time. Okay, they have asked the total energy dissipation. Okay, so it is the power into time we need to find. Okay, so if you check before t1, that means this instant, during this instant. Okay, so current is 0, voltage is non-zero, so power will be 0, so therefore energy will be 0. Okay, so here during t1 till t2, because after this instant, if you check after this instant, right, means after this point, if you check, yes, voltage is 0, current is non-zero, right, means after this also the energy is 0. Okay, so we need to find the energy during t1 plus energy during t2, only this much. Okay, so this t1 plus t2, it indicates the turn on transition. Okay, so here means we need to write the expression for this curve as well as the expression for this curve we need to write. Okay, so here, yes, similar to that of the previous examples, we have already discussed this type of example. Yes, what is the expression for this curve? Yes, if you check, initially it is a 600 and after that the slope is negative, so we can write it as a 600, that is the initial value, minus the negative slope. Okay, negative slope is change in the voltage, change in the y, that is the change in the voltage, that is a 600, divided by change in the time, that is a t2. So we can write it as a 600 divided by t2 into t. This is the expression for this waveform. You can check at t is equal to t2, right, but this waveform is valid only after this instant. Okay, so this expression is valid only during the interval t2, okay, so means for this expression t is equal to 0 means this instant, t is equal to 0 means this instant. Okay, so at t is equal to 0 it is a 600, so at t is equal to 0 means at this instant it is equal to 600. Okay, at t is equal to t2, if this is 0 this will be t2. Okay, at t is equal to t2, if you put here t2 it will be 0, so it is a 0. Okay, similarly, can we write the expression for this curve? Yes, it is a linearly increasing. Okay, so it is a slope is positive. Okay, so you can write it as a, it is change in the current is from 0 till this full current is, this is 100 plus 50, so 150. Okay, so you can write it as a 150, change in the current is 150 divided by time, this is a t1 into time t. Okay, so this is the expression for this waveform. Okay, so we can write during t1, yes, Vs is equal to 600 and Is is equal to 150 divided by T1 into T. Okay, similarly during T2 we can write, during T2 Vs is equal to 600 minus 600 divided by T2 into T, and Is is equal to during T2 Is is 100 only, right, this is a constant. Okay, so it is a 100 ampere or 100 you can write. Okay, so we can write energy dissipation, that is a E is equal to integration of power. Okay, so integration from 0 to t1. Okay, 0 to t1, it is a Vs into Is into dt, plus integration from 0 to t2, right, it is a Vs into Is into dt. Okay, so we can write it as is equal to, yes, integration from 0 to t1, Vs is 600 into Is is 150 into t divided by t1, right, into dt. This is the one thing, plus integration from 0 to t2. Okay, it is a vs into is. The 600 minus 600 divided by t2 into t into z. Okay, now we need to simplify it, right? So we can write it as is equal to 600 into 150. Okay, we can write 600 into 150 into or divided by t1. Okay, into it is a d dt t square by 2, limit 0 to t1. This is the one thing, plus for the second integration we can write it as, we can take 600 into 100 outside, so 600 into 100, okay, into we can write it as t minus 600 we taken it outside. Okay, so t square divided by 2t2. Okay, limit 0 to t2. Okay, so if we check, it is equal to 600 into 150, it will be equal to 90,000 upon t1 into t1 square divided by plus 100 into 100. Okay, so it is a 60,000 into, we can write it as a t2 minus t2 square divided by 2 into, from this one t1 will get cancelled, so it is like 90,000 by 2, 45,000 into t1 plus 60,000 into 1 t2 will get cancelled. Okay, t2 minus t2 by 2, so it is equal to t2 by 2. Okay, so we can write it as 60,000 by 2, so 30,000, so 45,000 into t1 plus 30,000 to t2. But what is t1? They have given t1 is equal to 1 microsecond, t2 also equal to 1 microsecond. So you can put t1 is 1 micro, 45,000 into 1 into 10 to the power minus 6 plus 30,000 into 1 into 10 to the power minus. So it is equal to 75,000 into 10 to the power minus. So in millijoule we can write it as is equal to point, sorry, in millijoule it will be 75 millijoule. Okay, and write it as equal to 75 into 10 to the power minus 3. 25 10 to the power minus 3 joule. Okay, which is equal to 75. So this is the energy dissipated, okay, during transition, turn on transition, 75 millijoule, right? So correct answer is, it is a 75. Is this clear? So this is about the question number 21. In the next video we are going to discuss the question number 22. Thank you.